Not bad. All right. Don't know how my audio quality is going to be on this, but we'll see how it goes. Wonderful. Hey, how's everybody doing tonight? Yeah, it's going to be a little echoey. The acoustics in here are garbage because I'm not in my normal place, so we'll just have to bear with me on the echo. Not a whole lot I can do about that. Even if I had the headset, it'd probably make it worse. That thing's kind of on its last legs. So forgive me for the audio quality, but we'll see how it goes. See what we can't get on tonight. La-di-da. I think Luke's still on vacation, so gonna be out here contending and doing the usual stuff. While he's out, might as well. If you're just joining the live, go ahead and tap the screen, get the like counter up, and go ahead and share the live if you've got anybody that is interested in this kind of topic. Maybe any friends that like biblical stuff, fossils, rocks, geology, all that kind of fun stuff we're going to be talking about tonight. Go ahead and I appreciate it. Thanks for sharing the live and hitting that like button. Let's see if we can get the view count up. I love interaction. Go ahead and put your, what do you believe? How do you think we got here? Why are we here? What are we doing on this rock? Love to hear your thoughts. Go ahead and put a guest request in the box if you want to come up. We can chat. Love talking to people. Find out what you believe. I can share what I think. I love geology. I'm actually an amateur secondary researcher for geology, primarily focused on geomorphology. And if you haven't heard about that big college $2 word, geomorphology is the study of how land formations got their shape. And I tend to look at things from a biblical young earth catastrophism perspective rather than the typical uniformitarian perspective. This is pro-biblical creation. So I do believe that we are in a designed order, but I don't subscribe to the philosophy of origins as it relates to evolution, Big Bang cosmology. I find issues with it. And I think there's strong evidence to support the opposite point is special creation. Looks like we got a guest in the box. Voter, I'm going to go ahead and bring you on. Hey. Can you hear me?
How's it going? Yeah, I can hear you.
Awesome. No, your audio is great. What do you
Excellent.
want to chat
Um, well, probably your pet specialty. That sounded really interesting.
about?
Did you
Ooh.
say geomorphology?
Yes, geomorphology. How particular land formations like canyons, mountains, stuff like that got their shape is a fascination of mine.
Okay, and in so can you tell me why the Rockies and the Appalachians are so different?
Okay. So the Rocky Mountains and the Appalachian Mountains, I haven't done a ton of in-depth research on those mountain ranges, but what kind of differences that you know about comparing those two mountain ranges do you take interest in?
Well, I mean, the heights of the peaks, the highest peaks, pointiness. I visited the Appalachians for the first time after living in the Rocky Mountains and was just shocked by how sort of smaller they were and more rounded, though still
Ooh,
very tall.
awesome. So I love the detail you brought up that the smaller mountains, and you were saying the Rockies tend to be taller than the Appalachian range.
Yeah, the highest peaks are jagged and enormously high, versus it's at least from walking on it on the Appalachians much less dramatic peaks and verticality.
Ooh, so that's really interesting to me. And so it's curious that there appears to be a pattern. that the lower mountains tend to be more rounded off. They're almost like more weathered, where the higher peaks in the Rocky Mountains and also the Himalayas, for example, which are extremely tall mountain peaks, are very jagged and have very sharp angular features to them. Now, this is curious, and there's a lot of good explanations that we could propose to try and better understand how they came to be this way. Here's from my perspective, from a biblical perspective, from a young earth perspective, is some of the grander features on the planet, like mountains, are a direct consequence of the global flood in our modeling, where some of the more minor features like canyons, rivers, streams, and stuff like that could be post-ice age formations, which in our model is a consequence of the flood and happens in the epoch after the flood. Circa, we're talking about 4,000 to 5,000 years ago. So interestingly enough, in our model with the global flood, we're still starting from the same starting positions as the conventional model, which would be the Pangea configuration of the continents. All of the land masses are conjoined together in one supercontinent.
At what point, wait,
Right.
what timeline would this Pangea be in? Just, I've been tracking you until now, and
Sure.
yeah, please explain the young Pangea thing.
Right. So young Pangea is similar to old Earth Pangea, which puts it about 300 million years ago when all the continents were conjoined together in the same landmass. That we both agree on between the conventional paradigm and a biblical young Earth paradigm. We have the same starting conditions. Now, as far as how that model was constructed with the young Earth model, if it explicitly states something, say in Scripture, like in Genesis, we'll have that as a presupposition in the model. But if it doesn't say, we're free to make presuppositions and then use them to make testable predictions and improve the model over time. So that's one of our initial conditions. Now, the landmasses are not together today. So if this were to be the case about 7,000 years ago, in the beginning when the continents were all together, what changed between then, 7,000 years ago, and now that the Earth looks so different? The continents are separated by vast oceans and they're not together anymore. Well, we believe that this occurred during the approximate 2-year cataclysm of the global flood. But instead of these continents slowly moving apart at the speed that your fingernails grow, like the conventional paradigm would believe, we just believe that this was rapid and catastrophic plate tectonic movement at the speed that you can run. We're talking meters per second, not centimeters per year.
Right, and centimeters per year produces volcanoes, right? Were there also massive volcanoes forced by the...
Yeah, same mechanism, right? When you've got
Right.
plates moving, that's going to produce friction and heat, and you'll have volcanic activity. We believe there's tremendous amounts, catastrophic amounts of volcanic activity during the flood and also the years after. It's not. We don't believe that Noah steps off the boat into the serene, peaceful world. There's still rebound earthquakes. There's still quite a bit going on. Not to mention the post-flood ice age is something that we also believe to have had dramatic and cascading effects on the world. But to bring it back, that's the framework, right? Generally, as a airplane level view, is a framework of what we're looking at to explain these mountain formations. So now, towards the end of the flood, when the continents are coming to their critical mass and movement, like continents like India are colliding with the Eurasian continental plate, forming the Himalayan mountain range, and most of the mountain ranges we believe were formed towards the end of the flood. Now, if the mountain ranges were very tall, the higher the mountain range would have peaked over the floodwaters, where the lower mountain ranges wouldn't have gone over the floodwaters, they'd still be submerged. At the end of the flood cataclysm, when the floodwaters are receding due to the cooling and the lowering of the new ocean floor basin that was formed by the spreading of the continents, that water would be sheeting off the continents, weathering down and smoothing out the lower mountain ranges, while leaving the taller ones untouched.
Okay, so were the Rockies then before the flood, and the water didn't reach up to the point at the top where it's
That's a
spiky?
good question. That's a really good question. I don't think that they were before the flood. I think that the Rockies are a direct result of the continents moving during the flood. So western in the Rocky Mountains are the western United States. So as that ocean floor plate is subducting and diving into the mantle, it's actually buckling up and uplifting the continent below it due to isostasy. So, just like putting an ice cube in a glass, if you were to push an ice cube down and then put so how can I put this? If you have an ice cube that's floating in the water and you put another ice cube underneath it and let go, it'll bounce up and you'll uplift that top ice cube. And similar things happen, but just on a much slower and much bigger scale with continents. So as the ocean floor plate is subducting underneath the continental plate, it's going to uplift that isostatic movement is going to uplift the continent, and that's what we believe is actually forming the mountains is the plate subducting under, which is the same thing in the conventional paradigm, but the difference is time. Did this happen very slowly over hundreds of millions of years, or was this a catastrophic rapid process, the results of the plates moving very, very quickly during the global flood, not all that long ago, are the two kind of differences. Same mechanic and explanation, but the variable is speed, is the
Well,
rate at which we believe this had occurred.
I'm a little confused because is it one or the other with respect to smashing in or fully subducting? Because you said it was a very quick collision. I wouldn't. Which one is it?
Well, I mean, quick being subjective to the conventional paradigm. We're
Quick
still
being
talking
like you're moving a continent how fast? One
like
mile per hour?
meters per second. Yeah, so
One meter
multiple
per second?
meters per second. Some of these things are. It depends. Not all of them are an equivalent speed. We don't believe.
And
Some
so
happen
this was happening
faster.
for how many years?
About two.
So 2 years at 1 meter per second.
Yes, but
And
not consistently at that rate. We're not like going from zero to that max speed to stop again. It would have been a bell curve, right? It's going to increase in speed and severity until the climax of it. When it equalizes out, then it'll slow down and stop. Or well, not stop per se, but significantly slow down because there has to be a cause, right? You have to have a driving mechanic if you're going to be flinging continents across the planet's surface about the speed that a human can run. And we
right.
do have that such driving mechanic to explain how the continents
Wouldn't that
could
also
move that
cause
far.
tsunamis? Or wait,
Yes, very big ones, increasing not only in severity and amplitude, but also in how often they are occurring as this
but
progresses.
not the Atlantic though, because the
All
Atlantic didn't exist yet.
well, the Atlantic would be being formed as the continents move apart from each other, so it's still possible to get tsunami waves inundating the land masses from the middle as well as water fills in as they separate.
So how fast did the water fill in then, if you're saying that there was times in which the water had only filled in the crack between continents versus submerging the whole world?
So it would. It's moving in that direction and that trend. According to the historical account of this cataclysm, all of the highest hills were covered. I believe about a year and some months into the flood. I have to go back and look at it to be particular, but it's the high hills at the time when we're stipulating that the mountains were formed towards the end of the flood as a result of the continental movement, and therefore wouldn't have been included in that statement that the high hills were covered about 50 feet deep in water across the entire planet.
So there was nothing that was not covered, or what's the implication there? That there were...
The implication is that all of the land masses were covered for a short time, and then the mountains were formed towards the end of the cataclysm and started showing above the floodwaters, and then the floodwaters recede shortly after.
And it's a 2-year period between these two events happening?
Yeah, between the first day of the flood, it says in Genesis 6, in the 600th year of Noah's life, on the 17th day of the month, the fountains of the great deep burst forth and the windows of heaven were opened. Okay. That point would be the beginning of the cataclysm, which we believe is a poetic description of a physical reality that humans witnessed that could very well be the first earthquake that shattered the continental shelf of the Pangaea megacontinent, and any subterranean water with the whole weight of the continent bearing down on top of one would have been thrust vertically, and could be a description of that. These fountains of the great deep bursting forth, being like some terrestrial land geyser type thing, but everywhere.
Right, but I'm more concerned about Europe and North America having touched. At what point during the flood did the Atlantic form? Because I guess how long was it between this point in which the flood started and the crack opened between the Pangaean continents and the water going above every high hill? Was that a 1 month period? Was that a 1 hour period?
You're probably talking weeks and months, not hours. In order to really, as this thing gets going, there's a scientist by the name of John Baumgartner. Have you heard of his work?
No.
Okay. So John Baumgartner in the 1980s, who's a geologist, was setting out to create a model or a simulation of the continental movement during the worldwide flood. In the 80s, the access to supercomputers you have is not very good. So simulating a sphere with independent sections that you can simulate the movement of the fluid of the mantle, you could only divide a sphere into so many sections before you crash the supercomputers in the 80s. So as supercomputers are getting stronger, he's able to run his model with more and more sections divided up into the sphere, until the early 2000s, supercomputers are finally strong enough to make a pretty reasonable modeling of the global flood, of how these continents would have moved in this time frame. So he gets the simulation to run, depending on where you put the subduction zones and where the ocean floor is diving into the mantle, and that is pulling the continents that are attached to it. He was able to put the subduction zones in the Pangaea pre-movement Earth in the right places to where the continents move how we believe they move, that India goes south and then it goes north and it's going in the right direction. And the whole geological community was really excited about this. It actually got posted in, I think it was Nature magazine. I forget which one. But they post like the diagram and stuff of his findings of the modeling, and how it shows the directional arrows, and then the length of the arrows indicate how fast the continent would have moved. And then it shows snapshots like...
I'm a little lost. Can you land the plane?
Yeah. So to answer your question on about how long would you start seeing the ocean form between Europe and the North and South American continents and so on, right, you would have to get a hold of that modeling, and really that would give you your answer as far as those time frames and how they're moving and how fast. And the driving mechanism is the density of the ocean floor having a greater density than the liquid mantle below. And that's what's causing it to dive into the mantle, because it's of a material of a rock that's more down.
Okay, and so the continent of Pangaea was relatively non-mountainous then.
Right. Yeah, relatively non-mountainous, more hilly, more of a temperate climate. So a relatively warmer climate than we experience today. You know how the depiction of like the Jurassic and the Triassic and the Cretaceous, like periods of the creatures that were alive and what the fauna was like and what the suspected climate and temperature was like, just warmer than today.
Much warmer.
We believe that instead of each one of those packages of strata representing an age of Earth's history, that in our modeling represents the strata that was deposited during that particular part of the flood. The earlier part of the flood, the mid, the climax, and then towards the end of the flood. Right.
Wait, was Hawaii there before, or it was formed during?
I would suspect that it was likely formed as a result of all the volcanic and tectonic activity during the flood and shortly after. But I wouldn't think that it would survive as is from before. Not in that state, anyway.
So the patterns on the Hawaiian Islands that are erosion are caused by receding ocean from. Well, are you saying that the Hawaiian Islands, the volcanic explosions happened while they were underwater, and then they were exposed when the water?
Oop. Oh, it looks like your feed cut out there.
Oh, sorry, I got cut off by a notification of low battery, so I may not be here for long. But my question is this: did the volcanic eruptions that happened to form Hawaii happen underwater, or was the water exposed as it is today? Did the explosions happen like?
That's a good question. Honestly, I don't have a direct answer to that. I haven't studied or looked into the volcanic rock on Hawaii, or even to the point where I think there'd be a testable prediction that I could confidently say that. But that'd be a good way to utilize this model of, given the parameters and the things that we have so far with the model that we believe to be true, what's a testable prediction that we can make about the Hawaiian Islands, and then how could we go out and find the evidence to either validate that prediction or discredit it and indicate that there needs to be something different with the modeling, something that we don't have correct. That's a good question, though.
Right. So if Mauna Loa did erupt into the atmosphere, that should be noticeable in the geological record, right?
Yeah, or at least the volcanic ash and the lava flows from that eruption, especially if humans were around and there's some kind of human record of it. Sometimes we have that to point to as well that can really help with dating specific eruption. I think one piece of evidence that's really intriguing is that in the 80s, John Baumgartner had predicted that if this is true, and the movement of this was relatively quickly, then the recently subducted ocean floor plates from the global flood should still be down there and should not have had enough time, with the cubic volume of rock we're talking about and the temperatures involved, should not have melted down to a liquid state yet. They should still be relatively cool compared to the mantle rock and still solid. The ocean plate should still be down there, was his prediction. He just didn't have any way to test for it yet in the 80s.
Oh, wouldn't that cause massive instability in the upper crust?
Upper crust, initially, yeah. That, I mean, we have mountain ranges and crazy isostatic movement, moving plates up and down and stuff.
So are mountains forming now faster than you'd expect?
Well,
if there's no subducted plate?
Mountains there's still isostatic movement today. Mountains themselves are still moving up or down, not violently, but we're talking like inches per year. There's still isostatic movement today.
But if there was a subducted plate, why would it not be moving more rapidly or more dramatically? as that plate changed to state.
So I'm not sure. It might be possible. The only thing I know that he was looking for as the testable prediction is that once we develop the technology to detect what's going on very deep beneath the surface of our planet, that we would detect these subducted, relatively cool, solid plates in the mid mantle that have come to rest on the liquid nickel iron core as a material that's not as more dense than that, but it's more dense than the liquid mantle above it. And that's exactly what has been found recently. There was a paper that was published, I think it was in 2011, called A Wrench in the Mantle of the Earth. And,
2011 is not recently.
well, recent in geology terms.
Okay.
It's a subjective term.
There was a paper published 13 years. Okay, go ahead.
And that's exactly one of the things that using. Have you heard of seismic? It's called, I think, seismography. What's it
Mapping
called? Yes,
using,
seismographic mapping.
yeah, it's similar to sonar, but in the rock
Yes, especially utilizing when earthquakes occur and triangulating
Right.
seismograph data on different points of
from
the
other
planet.
sides of the globe. Yes.
Yeah,
Okay.
yeah, yeah.
And this is how they pointed out that there might not be a circular or, I guess, spherical iron core. Or that was one of the hypotheses, right?
I don't know if that was a prediction of either of the models. That's the first I'm hearing of a not perfectly circular core. That's
Oh,
interesting.
no, there was, I mean, that was, I think, why I've heard of seismography, is because it
Oh,
was in the news recently, because they were basically looking at, well, these sort of actions that have happened earthquake wise at various sides of the globe and determining the speed of how the sound waves should have gone through various layers and determine that there's a potential for the core to be non-spherical, and
yeah,
that could be contributing to the the fact that the magnetic field wobbles.
perhaps. I think the erratic movement of the magnetic fields over since we've been measuring it past the past 200 years is really odd. And it's something that I wouldn't expect to find in a very uniformitarianistic old Earth scenario to have basically erratic movement with the magnetic field.
Right, and if the core is non-spherical, then I think that I don't know if that affects that theory or not, but it was sort of associated with some other theories, including the formation of our moon, and how the fact that Earth's core is not spherical could be because it has contributory matter from the other astronomical object that hit Earth and broke off the moon. Those are the theories that are being put forward as to why
Yeah.
the center might not be spherical.
Or what if it has to do with giant oceanic plates just touching it a little bit too much and making it squish on the side? I don't
Oh,
know.
I don't think that's possible because of the depth, right? I mean, like if you to
Maybe.
go a third of the way through the Earth, there's definitely no crust there. I mean, like the core itself is, yeah. There's
Yeah.
3D simulations that they put out get from this seismography data.
Yeah. Yeah, you're probably right. I don't even think it can reach it. I'm just trying to kick that new piece of information around and playing with it. First I'm hearing of it, like a
Okay.
non-spherical core.
Well, I'm glad to. I'm just relaying pop news. I don't necessarily have an opinion on this. I'm interested in how this answers questions because, yeah, like Hawaii. I'm just thinking of different mountain ranges and erosion that we're talking about. So Hawaii, did it form after or during this flood? And is the weathering that we see on the different islands how it's it indicates that like one's been weathered a lot longer than the next, seems to indicate that these eruptions didn't happen geologically in the same like decade or whatever it would seem that would be the flood timeline. It seems confusing to me. I'm trying to get my head around what you're saying. Can you explain to me why these Hawaiian Islands look like this if they happened at the same time?
Not that I could say with any amount of confidence. It's not an area of study that I've spent a lot of time on. I can.
So what is your research then? You said you had hands-on
Yeah.
research.
So, for example, have you seen images of like folded mountains, for example? They're basically all.
Sure, in sort of high school textbooks and
Sure.
whatnot. Yeah.
Yeah, so like folded mountains, for example, I should be able to pull up here. It should let me pull
So
up.
you visited folded mountains and examined rocks there.
Not that there's stuff I have visited personally that has more to do with cross bedding than folded mountains. But just as an example, let me go through it. There's one in Carbon Canyon, it's in the Grand Canyon. It's a massive rock fold that is in Carbon Canyon, a few miles off the main canyon. And this particular limestone, or I think it's sandstone, this particular sandstone that is consistent, it's normally horizontal, it's normally flat, mile after mile, is buckled along this fault line here. In present day, all of that rock is solid. It's rock. It's not malleable or soft at all. It's sandstone. It's like concrete. But it's consistent with the type of rock it is that is normally flat-lying. So one of the questions is, how did this form? When the fault cracked and there's an upwarp of a few hundred feet, was this rock relatively hard and already cemented when that formed, or was it still malleable and wet and soft at the time? Is one of the questions geologists have about this formation in particular. So, and this is the kind of field of study that
Is the question whether the rock was soft at some point?
yes, was it basically soft, like intermixed with water? That the quartz crystals within these sand grains hadn't solidified yet, that it was still dissolved in the water at the time, and it hadn't dried out and then crystallized. That's what, and causes it to be hardened. Similar to how cement dries today will be.
Okay, so like this whole thing was all wet rock and solidified at one point was it going over a river or what? Yeah, why is that what you're studying? Why this is slanted?
Yeah. So one of the explanations for this in the conventional paradigm is that at the time, all of these were completely consistent, flat, horizontal layers. And then this fault had changed very slowly over millions of years, and that slowly bent with some kind of heat and pressure while it was already hardened, is one of the explanations. The
But
rocks
with heat and pressure, it's softened a bit, right? How hot and how hard would it have to be pressed for it to become vaguely malleable? And would that happen at the same rate within each layer?
Those are phenomenal geology questions, and questions that could be testably accounted for with microscopic samples.
Okay.
So if there were some kind of heating process that more so transformed these rocks, allowing them to bend and to meld, you would expect to see a lot of brecciation of them actually cracking and breaking, even on a microscopic level, as well as processes where they're fusing and melting together under immense heat and pressure. Whereas if this had formed while it was still watery, right, while it was still like sand on the beach, if that had occurred while it was still wet, you wouldn't expect to find any evidence of brecciation or any of these kind of like heat and pressurized rock going on. You wouldn't see the evidence of that heat and pressure. But we
That,
need the microscopic samples in order to test for either of those.
but you'd need to have some force that is bending it around a surface, right?
Yeah, so that would be the plate, the tectonic plate here. There's a fault line. The plate itself brecciated, it cracked, and one part of it was down, the other part was upwarped a little bit. So it used to be one tectonic plate that cracked. So there was some kind of fracture, and that
Yeah.
runs for miles. That there's hundreds of miles long. It's a really big fracture. So that it's called the Kaibab upwarp, and
Yeah.
that is what would be the causal factor for that to bend like that. But the question was when and how fast and in what state.
Right. So you're saying that it was in a liquid state when the fault line occurred?
Yeah, that's what we're proposing in our modeling, that this would have occurred. This would have occurred towards the end or after the flood. That fault occurring, causing that before it had hardened. So it's still got to be within, while it's still submerged in water shortly after these layers were laid down by various tsunami waves during the flood, and then brecciating after that. Then we would believe that it hardened and is carved out by a dam break during the Ice Age period shortly after the flood. Like the whole Grand Canyon being carved out is a series of meltwater floods, it looks like.
So why was the ground liquid? Because it was deposited by tsunamis.
Right. Yeah, those
And
water that carried in those waves.
and so why would this pattern happen in terms of layering on dirt? It wouldn't be consistent width in different vertical directions, wouldn't it? I mean, I've tried to, I've seen what beach lines look like, right? With sand blowing up, it sort of flattens at the top, and then on the sides, it cuts off more sharply. So why would these be the same width?
Um, some of these are similar with, but not exactly identical. So
Like if a tsunami leaves wave and pulls it back, why would it be relatively evenly width on both sides of this different curve?
that's a good question. So I've got an example here that can kind of
Yeah.
help explain a little bit of that process. So this is off of an interstate, and do you notice any kind of pattern in these rocks that seems out of place? I have pictures.
I don't think so.
So this is about 200 feet farther inland, where it's the same cutaway of rock.
Okay.
You notice a pattern. You kind of have to look
I mean, I
closely.
can see that it's the different layers of rock are well, they seem to be at a horizontal diagonal line,
Yeah.
which doesn't. That's not how waves deposit sand.
No, it's not. They're all in the same angle
Yeah,
of
the
this
same
like
angle.
diagonal pattern.
Right.
That's interesting. That
Is
is a
it?
feature in geomorphology known as cross-bedding.
Okay. I mean,
Cross-bedding.
it's very common, I think. I mean, I think I've seen this driving along the highway. It doesn't seem
Yeah.
uncommon. Yeah.
Cross-bedding is actually extremely common. And one of the interesting things with that is mechanically, we find, especially, for example, with flood deposits from tsunamis, when there's a body of water that's carrying along sand grains and sediments with it, it'll deposit them in these kind of cross-bedded diagonal patterns. where it's building up. Let me see if I can get my finger here. There we go. So it'll be building up sand grains here, and then as they're cascading over and they're falling down that slope at the edge of where the packet's being deposited, they'll start stacking up, and they'll stack and stack and stack and stack until they reach the critical like top of the height, and then it'll start cascading and making another layer. And it builds layers right to left as the water moves along.
I've walked over a sand dune. Yeah, it's sort of the same experience, right? Depending on the size of the particles and I guess the viscosity of the liquid they're in, it's going to form at different angles.
Yeah, I think the size of the sand grains, the consistency, how their ability to be kind of chamfered or broken down, or stuff like that's going to have an impact. But we see this mechanism as something that we can test small scale. I've seen these really simple rigs that I've seen people build, or it's like plexiglass and a straight, like rectangular column that you can see through. And then they'll just simulate sand mixed with water and then just send it downstream, and then they'll see from the side profile what it's doing, and it builds the same kind of pattern. Small scale, which is really cool. Just what we're talking about is what size water flow and how much volume of material do you need to produce that? And along the highway, this goes for a while. This is a huge formation. So it's just stuff like this I would point to as what kind of flood must have produced that, because this isn't like, a little package of strata that's all the same rock. And then it's just one on top of the other on top of the other. This is, about 20 feet thick.
Yeah, where did those pieces of limestone come from, and why is it consistently different groups of thicknesses?
Yeah, or like, why is it, how is it all deposited with these cross-bedding features? And
where did each of these like layers come from? Is it like different types of rock that managed to be strewn about in it? Like, are different tsunamis hitting different land masses? How is the
that's what I'm thinking is, let's say if we do have ocean floor plates subducting very quickly, the earthquakes happening are going to be bigger and bigger as this picks up in speed. And as those waters are dragging inland, it's picking up not only the marine life and the sand and the shallower lands, and dragging and depositing all that further inland until it runs out of energy and then starts a recession phase and drains back into the ocean basin and winds up for another punch effectively. So what I'm looking at is not like fossils as the story of the progression of life, but rather the destruction of entire ecosystems as they're being dragged and deposited inland, one ecosystem at a time. So it's a graveyard on top of a graveyard on top of a graveyard until eventually it consumes them all. Like the biggest dinosaurs and the land creatures that can move and run, your monkeys, your birds, all that stuff, you find most of those fossils in the western United States at the highest elevations.
And this all happened within 2 years. So there's how many tsunamis within those 2 years? And there's different ecosystems that they hit as they get to higher ground?
Right.
When does it take? Yeah, I guess I didn't. The question I asked a while ago is like, when did it get to the peak level where everything was submersed? Like what's the time between the first, say, crack and that time? Is it maximum 2 years, or it's likely that happened within the first 3 weeks? Or like what sort of timeline?
So the biblical narrative that's in the oldest Hebrew writing that we have sets a timeline that looks something like the flood begins, and I would have to look at the exact dates, but we're talking maybe 8 months
Eight
until
months.
the waters are something around there, I think, until the waters are covering everything. And you're looking at about a year and a half to 2 years by the time the the ark is landed in the mountains in the Middle East, and you've got some kind of terrestrial life possible, even though that the recession and this whole process isn't completely good done. There's still probably receding floodwaters, there's meltwater dams, there's stuff that's happening, but from beginning of the flood to you've got life kind of restarting in the Middle East and like the Mesopotamian area is a year and a half, 2 years, start to finish.
Okay.
Um,
And so in those first 8 months, you're saying that as the general water level rose, it was also depositing different layers of dirt as it was rising. Every whatever one of these striation is, right? Is that what you're saying?
yeah. So as this is beginning, you would have small earthquakes on the edges depositing in smaller localized areas. And then the next ones that are coming are bigger, and they would be happening more frequently and bigger when they do happen until it's at its highest point, about probably halfway through. There's plenty of detailed timelines that more so visualize that small section in Genesis to get like a better view of the timeline, but generally
So
that's what I'm talking about is
so like which
these.
direction are like if you're talking about you're talking about fossils, right? Like in which direction is dinosaurs versus chimpanzee or sort of hominid fossils? Like, are they deposited later? Does that mean that they were higher up in terms of like being hit by later tsunamis, like higher up in terms of elevation, maybe?
So I
I
think
guess
it's
who's higher and who's lower? The things that are like traditionally
yeah.
considered older versus younger.
Right. So, in the highest layers, we're finding dinosaurs and hominid fossils and monkey fossils, as well as your birds, crocodiles, turtles, are all found in the highest layers. Like,
So the highest layers means that they were deposited last,
right.
meaning like the very last tsunamis that happened. So it was like everyone, all the animals had gone to higher land as the oceans had risen. Is that what the
Yeah,
claim is?
that's kind of what we're looking at is that anything that could run inland and get to higher ground spent the time to do so for the most part. The things that weren't capable of that kind of movement, like your aquatic life, your plants and stuff, the trees aren't going to be able to run away, are buried in the lower layers. And then anything that could attempt to evade the flood in any way it could, we see evidence of that, like fossil footprints, for example, are common. We find evidence of creatures leaving indentation in the soft sediment that are later fossilized. Of creatures that we find the bones of, we find the fossils of higher up in the strata.
So higher up in the strata means the basically the closest to the surface,
Yeah, closer to the surface, we'll find
and
the actual
that's
fossil.
where that's where the dinosaurs are.
Right.
Okay, and what type of plant life is found at that layer?
There's still plant life found in that layer. I'm not as particular about like the different scientific names, but there's aquatic life that are found in that layer as well. For example, the dinosaur monument is a package of strata that is chock full of fossils in the western United States. And there's also aquatic life fossilized along with the dinosaur bones there as well. There's clams in the shut position strewn all throughout the dinosaur monument, along with the dinosaur bones that are found with it.
And at that time period that they were fossilized or they died, what was supposed to have been going on?
So the time period when they were fossilized I believe is towards the end of the flood cataclysm, buried together in the same water and sediment that killed them. Whereas in the conventional model, that's supposed to represent an era of Earth's history. But what's curious is that they're buried in a mass grave, all mixed together, and a lot of the bones are disarticulated. Each individual bone isn't found grouped or clustered together with the same animal. It's a graded bed with the bigger bones on the bottom and the smaller bones on top.
And what does that mean?
It's challenging if this was just business as usual in that era of history and they happen to be fossilized. But if the animals that are represented in that in the dinosaur monument collection of fossils all died in the same cataclysm, it's a lot easier to explain how these are fossilized together in a grouping.
But these were they warm-blooded or cold-blooded?
It's a mix of aquatic and mainly, I think mainly dinosaurs. I'm not sure what other specimens are found in that particular formation, but I know for sure you've got dinosaurs and clams are two that I know are there represented. There could be more. Um,
And so this is, say, 7 months into the cataclysm. You said it was sort of at the top of
yeah,
the
it
thing. Okay.
definitely be towards the latter end when the waters are completely inundating the land masses. Also,
And they had escaped the previous tsunamis. Is what you're
correct.
saying.
Yeah, because they're fossilized in higher layers. The lower layers would have been deposited by the previous flood flows, and you
So
find out.
were they transported when from where they were nesting, for example, or was this within an already existing cave?
I think they would have been transported. That it's much more likely, I would believe, during that type of event for them to have been moving, and this wouldn't have generally been the area that they would be inhabiting or living in. That they would have abandoned wherever their previous kind of habitat or environment was, just for sake of heading heading to high ground.
Right. No, but I mean, like, were they dispersed? Like, how quickly were they fossilized? Like, were they dispersed? Like, or were they basically their bones were left where they died? Is my question.
That's a good question. Just looking at they're disarticulated. So it appears that there was some amount of decay that happened, or possibly scavenging that happened from aquatic animals or birds or something. And then the bones are deposited in kind of like an awful bone soup mixed with sand grains in more of a graded fashion. Because remember, they're
But they're
not
mostly
found
together, right? They're
right,
mostly
right.
together. It's
They're
not.
not.
They're mostly together. It's not like what you would imagine if a tsunami were to pick them up and like drop them off on wherever it lands, right? They
Yeah,
would
like
be,
if a cow
they're at
got
least in a
slain by a
group together.
tsunami, you'd still find most of the cow together.
Right, but you wouldn't find it with other cows in a group, right? Would
Unless
you?
you did a coastal cow field, that'd be awful.
Okay, so does what was the climate then? Because like at the beginning of this, you would imagine there like massive volcanic activity. You would basically the entire sky would have been ash by the time that this family of dinosaurs died, correct?
Yeah, it would not be a very pretty picture, for sure. Which means that losing a lot of the sunlight is going to relatively cool some of the planet as well. Not, I mean, not catastrophically, but you'll have some cooling, which is going to contrast against
Wait,
the
how much
relatively
cooling? Because I mean, only a little cooling can be catastrophic. But how much cooling was there?
that I don't have a solid answer for.
I mean, I've seen all these models that people talk about with climate change and pollution and whatnot, and science fiction, and it seems that if the cloud, if the sky is completely covered in ash, you drop at least 5 degrees centigrade immediately globally.
Yeah. And I think that's reasonable, especially because at the same time, you've got the opposite direction. So you've got some cooling going on
But
in
then
the
there's hot
atmosphere,
water coming from underneath the earth. What temperature
which
is that water, do you think?
probably warmer, given tectonic activity, especially the continents moving the volcanic activity.
So
Pockets where it's warmer, especially at the surface.
do you think so? The water that burst in to like form the Atlantic, or at least raise the and generally raise the sea level,
Yeah.
was is from below the Earth, right? So it was well above 100 degrees centigrade, right?
Yeah, I'm probably, especially in pockets. Dispersing though, it's going to disperse a lot of that heat towards the surface layers of the water. So you're
But
going to
if you're
have,
raising the like total sea level by what is it, 100 meters? Is that what you're claiming, or is that like what the highest mountains were at the time?
proportionate to the highest hills at the time. It's like from the present day coast, it's kind of hard to gauge. But yeah, just generally about we're not talking the heights of the highest mountains, like not 12,000 feet.
Right. So you could say 2,000 feet.
Sure. So let's say somewhere around there.
And so there's land that would have not been hit by the first tsunami if it was that low of a elevation.
Right. Yeah. So
Okay.
the
And then they
beginning.
would splash more and more inland every time there's a tsunami. Okay, okay. I'm trying to figure out where the water's coming from inside the earth, right below the crust. It's like boiling hot under deep hot pressure, and it manages to raise the surface level of the water globally by 2,000 feet. Wouldn't
Right.
that raise the temperature of the water significantly?
Pretty significantly, yeah. But evidently not high enough to it completely eliminates all sea life across the planet. But enough to
Really?
where you're going to have catastrophic evaporation. It says it rained for 40 days and nights straight.
Right. So I imagine there probably was catastrophic evaporation, but not like eliminating the whole oceans, but like it must have been not only ash, but dark clouds of water vapor mixed with ash
Yeah, especially with
as
volcanic activity going on.
with the volcanic activity and the temperature of the water raising significantly, and then the volume of the oceans rising significantly at the same time as massive tectonic stress. So okay, so this is happening all within a 8-month period, and so how come these striations here are like when did they solidify like one particular layer? Like at during the time span of how many days or weeks?
Well, that's a good question. I think it's going to depend on where it's at, its elevation, what's going on around it. There's going to end up being more to the story.
But supposedly this is an ocean floor, right? And a layer of soot has been deposited by a tsunami, and then the next week there's another tsunami, and the next week there's a larger tsunami hitting different parts of the world. So between that point of this sand being deposited and then the next tsunami, it's at most a week, at most a month, and during that week-long period, how does the like liquid rock solidify? I guess, or the sandy loam, or whatever you would say, into
Yeah,
a
it's.
distinct layer.
I think it's gonna depend if the water is still present or not. When it's gonna actually crystallize and solidify.
Right, but
Um,
if the water is gone for say 5 days, is it able to crystallize and solidify in
It
five
could.
days?
Yeah, I think if the conditions are right, it could. I think it's possible that you could have some layers of it solidifying during the flood cataclysm, even if they later get encapsulated and buried by more water later. I think that's possible.
Okay, and
Because,
does that
like,
work with limestone? I'm just trying to understand which
yeah,
layers of sand that would work with. So you can cure limestone in a 5 day period, such that it's solid and contours the shape of a previously solidified rock.
so I guess one question would be, do we find fossil footprints in limestone? Because if the answer is yes, I think that would indicate more closely that it's possible. Like, so,
Wait, I'm confused. What does?
fossil footprint. If this
Yeah,
did form while it was mud, while the sediment was still wet, in order for it to be impressionable by that
yeah.
dinosaur footprint, um,
Right, but that means that it's plausible that this happened within a 5 day period that it solidified.
right, which which means that there's some amount of time in between when the water's inundating the land receding and before it was completely immersed, it looks like.
Right, but if you divide the number of layers by the amount of potential time, you're talking about an 8 month period, then the amount of time between layers deposited has got to be, yeah, I mean, less than a week. And so is something curing these layers in between those like 3 days that it dries out between one tsunami crashing and receding and then the next one crashing and receding?
Well, I guess the only places, because just because it's possible for it to dry and cure during the flood cataclysm, I would say it doesn't mean that every layer has to have undergone that process.
But everyone that has an angle or a curve must have.
Like the folded mountain ranges or
Yeah.
so.
For
Yeah.
example, so every layer of a folded mountain range.
Appears to have been malleable at the time when that formation had occurred.
And so, yeah, what are the typical layers? Are we talking, yeah, limestone, granite, quartz? Are these quartz crystals forming? Or I don't know. I don't know. I'm not the geologist, so
Yeah.
I'm interested. Like, do each of these layers have the ability to solidify within the 5 day period,
I don't know if it's within a 5 day period. And
or
remember,
2 weeks, or whatever? I mean, like, if you're talking,
surface rock, like, so if you had some limestone that is intermixed with water and potential quartz crystals that haven't solidified yet, and it's malleable and it's soft,
yeah,
just the surface could probably cure faster than anything that's deeper, right?
right,
Whereas the mountain ranges and like the folded mountains would probably take much longer for them to like cure or like harden out, so to speak, than just the surface layer to like solidify a footprint, I would think. Because those would be two different rates. You're solidifying and drying
right,
out
but
rock.
right, but you're talking about solidifying and drying out how many layers of rock within 8 months?
Oh, the mountain ranges themselves, especially like the examples of some of these different folded mountain ranges, wouldn't have necessarily had to dry out within 8 months. Remember that, like that kind of 8 month time frame is about the middle point where there's the most amount of water covering the most amount of land. Not necessarily indicative of when these formations would have solidified and hardened. That could have been much after the recession phases where the waters had sheeted off the land masses and left a lot of these exposed, that we would have them solidifying and hardening. So that could be years, a few years, 50 years, 100 years after the flood to where it's completely hardened.
So
Not
if
necessarily
the
hard and
different
burn.
these different materials harden at different rates, right? You would say for different striations, not all of those rocks would solidify at the same rate, correct?
Yeah, it's also probably going to depend on how much material you're talking and the environmental conditions, but certainly within a threshold. Like, I don't think you can say that it would have taken 30 million years for them to solidify. Just
Right.
given,
No, but I guess what I'm saying is that would one layer that solidify over top a layer that's not yet solid, that's in a sort of semi-liquid state, and would it form in that shape? Right? Wouldn't the mass of the heavier, or maybe not, maybe it's not heavier, but like the solid layer pushing down on these liquid layers, wouldn't they have to dry in sequence in order to have this shape?
I don't think they have to dry
Or they
in
have to
sequence.
they would have to, at least the lowest layer ones would have to be faster in terms of turning solid. Or do you think that, the middle, like some of these, let's say these light layers and the dark layers, one would take 10 years to solidify, one would take 3 months.
Sure.
Would
Well, and even
and
if that's the
they all
case,
start at the same point, and then because they've been deposited all within the same 7 month period,
yeah.
they would stay in this pattern. Is that what you're saying?
I'm saying it looks like they were all laid down horizontally by water flows and then were bent by tectonic movement violently during that short kind of 2 year window. And then as a result, after the waters receded, they hardened and dried out in that state. And whether some of the rocks took slightly longer or less, the end result is they're all dried out and hardened at the end, wet when they were moved, and then dried out
So
after.
you're saying these striations that are vertical right now
Yeah.
dried out that way,
Yep. That's what it looks like.
and they didn't spread out. The parts that were
Well,
liquid
some of them,
didn't
it
spread
looks
out
like
over the
some of
ones
them did.
that were wet. No,
We
it
like
looks like
lost
they're
the
about
left
same.
half of his ear.
Yeah. I'm not sure that's what this would look like. Have you, like,
Yeah.
it really seems unlikely that, but I guess
That-
that's your area of study, right? So you've done
Yeah.
simulations with like different like groups of sand and whatnot to verify that it's possible to create this kind of shape.
Well, I think you can kind of do whatever you want on small scale. The $1 million question is, would this volume and the amount of time frames that we're talking about in our modeling make any sense? This one's kind of interesting. Have you seen this mountain from Peru?
I have not.
That it's called Rainbow Mountain, kind of tongue in cheek. I'm sure there's a more fancy name for it in its native tongue, but a lot of us just call it Rainbow Mountain because, well, it looks like zebra striped gum.
Sure, yeah, it's really cool. It looks kind of like Jupiter's surface.
Kinda, yeah. And it's not just this one hill. There's many hills along this range that have similar features. Not as extravagant. This is probably the best example, but there's other that are still very similar to this kind of horizontal, like along the landmass stratification. It's really peculiar looking.
Okay, and so how did this form then?
Beats me. It really kind of throws geology on its head because strata usually doesn't go sideways, but this one does. I don't have a really high level explanation. I just know that this is a topographical feature that is very different than a lot of the stratification we see, and there's probably a better explanation that I can come up with ad hoc.
So this is in Peru.
Yeah.
Then this is going to be one of the newer mountains, right, in the Andes.
Yeah,
Or
but they're still not terribly tall. Like, look at the elevation. You've got tourists here, so it can't be that tall.
right, right. But one of the ones created. But actually, I guess you're saying all mountains were created during this flooding time period.
Yeah, as a result of upwarping and buckling of the plates moving, and usually underneath continental shelves, causing these upwarps. And then the lower ones were vastly eroded by receding floodwaters, depending on the elevation.
And so, how is this mountain made?
So it does look like there was a significant amount of erosion because they're not very jagged or angled peaks. It's definitely a lower one.
So
But
erosion
why?
happened after the depositing of different layers?
I'm not sure. I think one thing that'd be interesting to find out is like if there was like an excavation or like a cutaway of one of these mountains. I want to know what the layers look like as like a side angle. But usually I'll find that if there's like canyons that got carved through the rock. I'm not sure if there's a good example of that in that area. I don't even know how much serious geology has been done in Peru around this area. But it's just really peculiar. I don't know. This is the kind of stuff that I would love to go visit and study and learn more of. I don't know if I'll ever have the pleasure to. Um, there's another one that I've got all kinds of wild stuff. So, or like coal, for example. I have done a fair amount of investigation on coal.
Oh,
And
that's an interesting pattern.
this is a coal mine. That's actually mining equipment. That's it's not the greatest quality picture, but you notice the pattern is that you've got these pencil straight stratification lines that runs throughout the coal seams, and each coal seam is extremely thick. You're talking a couple 100 feet thick, and then there's stratification of different clay and different materials on top, and then another packet of coal. And that's not unique to just that coal mine in Pennsylvania. All of the major packets of coal that we find across the earth share these features, where it's these flat planes on top where the coal seam ends, and a similarly flat plane on bottom where the coal seam begins.
Okay, and so these layers were deposited between these two chunks of coal during the flood era?
Well, what's coal made out of?
I don't know. It's carbon, right? It's
Yeah, you're right. It is made out of
compressed
carbon.
carbon, right? Yeah. So does that mean that's the ashen atmosphere that was falling down from all the volcanoes that exploded and darkened the sky for how many years was the sky dark?
That's a good question. It
Must
had to have at least been during most of the cataclysm and then some of the era afterwards to clear up. You've got
Yeah.
a tremendous amount of volcanic activity we're talking about.
Might have taken what 1,000 years to clear up.
I actually think that the Earth is still healing from this. Like, yeah, the Earth is warming. I think it's still recovering, to an extent.
No, but the amount of ash we have in the sky is not.
Yeah, it's definitely gone from those plumes for sure.
I mean, like
So,
even like 1,000 years ago, there was almost no pollution in the
right.
air, right?
Yeah, so it had to have been
Probably
within that
two
time
thousand
frame
years ago too.
for at least the ash to clear up. And with the coal, here's one thing that I think is an interesting take on at least the formation of coal. This, do you recognize that mountain?
I don't know. Is that Mount Rainier? I have no
No.
idea. No idea. Is it? It's Mount St. Helena after the
Yeah, you
explosion.
got
Yeah.
you
Okay, I
got
got
it.
it. I knew it
You're
was in.
two for two on coal being carbon and Mount St. Helens. That is the side face of Mount St. Helens after the eruption. And what you're looking at
Right.
is Spirit Lake. And the unique feature about Spirit Lake is there's a floating mat of logs that coat the surface of the lake that are a direct result of the 1980 Mount St. Helens eruption. When a lava flow
Right.
that blew off the north face of the mountain, the forest got wiped out, and a large amount of those trees ended up filling Spirit Lake. And present day, none of them have any stumps or branches or bark.
Okay. And so how many years has it been?
Well, it was a 1980 eruption,
1980.
so we're talking 40 years.
Yeah. Almost 45 years. All right. So, and these have definitely not turned to coal yet.
No, but I think we have the right conditions that would make coal possible in the bottom of the lake. Because all of the tree bark and limbs and roots and branches that came from these trees, after they get immersed in water, sink to the bottom and form peat layers.
Right. Okay, so there's peat at the bottom of this lake, but that I mean it's 45 years. We're talking about 8 months of where a tsunami has deposited these other striations on top of this coal, right? So did the trees from the explosion turn to peat moss and then get solidified into coal within those 8 months, or was
So
it
I think that basically what we're looking at is, and this was geologist Steve Austin's work. He wrote his dissertation on a floating log mat model for the formation of coal. And he proposed that to create the packets of coal that we find, and he was studying this particular coal mine in Pennsylvania, that
right?
if you had enough vegetation floating on water, that it would be shedding all this organic material and forming layers. If that was then covered by another package of material, you have the right conditions to produce coal. In fact, if you've got clay mixed together as a catalyst with the carbon, with the organic material, and heat and pressure, you can produce coal in a matter of weeks.
Where's the heat and pressure coming from?
So the weight of not only the waters above, but also these packets of sand grains and rocks and these layers that are forming on top is your pressure. And then you don't need a lot of heat to form coal. It's relatively mild compared to other geological processes. And as long as you've got the catalyst, the conditions are right, mixed in with clay, you've got the right conditions that they've made coal in a lab small scale in a matter of weeks using these kind of similar conditions, trying to replicate what they think would be occurring during the flood with a little, heat and pressure proportionate to kind of the scales we're talking about, at least
Heat and pressure over what time period?
matter of weeks.
Wow, that's cool. You can produce coal from peat bogs by pre- pressurizing it.
Yeah, you can produce coal in a lab. It's probably not going to be efficient. Like the amount of energy you're putting into this process isn't going to be what you're going to get out by burning it for
Yeah,
fuels. So it's going to be a loss scenario. But yeah, it's possible. We can make coal. It's probably just not going to be useful in industry for the most part.
that's interesting. I didn't realize that. Okay, and
Which
so
which
so
then
so wait.
that's what
Here's the
gives
question. Then you had there's two. You said there's two layers of coal though. So okay, so the first layer of coal gets covered by subsequent layers from tsunamis, and then cooks in say like the first 10 weeks, and
yeah.
then
It's got
another
all day.
and then another flood happens that deposits more trees, and then that gets covered by sediment, and then that cooks again within like a 7 week period. Is that what is that how you create this?
You could. I mean, so this got excavated. Like this coal mine actually got dug
Yeah.
out later. So it's got a few thousand years to. It's just plenty of time. But I think it's largely done with that process during and shortly after the flood because it's only going to become relatively cooler and less pressure as the event kind of subsides and things return to present day normal.
So yeah, in this scenario here, where is sort of the ash layer? Is that baked into the coal layer?
You'd probably have to get right up on it to better answer where the ash layers are at least in this example of this package of Strata, but I wouldn't doubt it that you can find ash layers here, whether or not it's mixed in with the coal or in the strata above it.
Why would it be in the strata above it?
Well, you could have
You'd have
you
a
have the
wave that
conditions
happens
to have
before the yeah,
eruptions basically anywhere there's a fault line.
right. And then the ash falls on top of the ocean and then settles to the bottom of the ocean evenly? Is that what's
Well, it could. It's probably going to depend. So sometimes the landmass is exposed. So if it was exposed at the time, you'd probably get a relatively flat, really concentrated ash layer. But if it was there was like a tsunami going on at the time that particular ash cloud was falling down, it'd probably be mixed in with the sediment more so or distributed. I would think.
okay? And then like a tsunami, and 2 weeks later is not going to be able to like wash up that layer of ash that's been deposited.
It'd probably bury it for the most part, I would think, with just the next package of sand and strata and water that's bringing in.
Bury it. Wait, okay. So if you have like an ash layer, like and we've probably seen this, right? Like Mount St. Helens probably has, it probably happened then. You have an ash layer, and then like a tsunami hits a place that's covered in ash within, a week or 5 weeks or whatever. Is that ash going to stay evenly distributed? I imagine it's light enough that it would be picked up by whatever floodwaters would be coming in.
That's a good question. I know in the geologic column, there's really defined ash layers. They're typically not extremely thick, but they are there and they're amidst the strata.
Right, that seems like if there were, frequent flooding events, that it wouldn't be distinct. Like it wouldn't be an evenly distributed layer.
I don't know. But what if the layer that the ash is falling on is still relatively wet and still intermixed with water? Would
Well,
that
then then the line wouldn't be so well defined, right? You'd have a blended line.
well, I mean, but it wouldn't get like washed away, kind of, is what I'm thinking. It would
Right, but
still be there.
it would, I mean, but it would, it wouldn't create a very distinct line, right? Because it would be bled into the layer below it as being intermixed. I'm trying to figure out how you can get like a very distinct striation of ash in a scenario where there's frequent flooding.
Right. Yeah, I think that's a good question. If we were able to find an example in Strata where we can pinpoint one of these striations and study it, that'd be an interesting point of study. I just kind of thinking of it abstractly, I think it's possible given the right scenario, but it'd be interesting to look at samples to see what we actually find in
Are
some
there
of these layers.
are there examples of fossilized layers of previous like known and documented volcanic actions? Mount Vesuvius, for example.
Yeah, but so those eruptions that are recorded in human history, I think we can find the lava flows that were belched out from those eruptions.
But we can't find the ash layer.
I would think we'd still be able to find some evidence of an ash layer. I don't know how it would compare though to ones we find in the geologic column. I'm not sure. I haven't had the opportunity to study just ash cloud layer deposits very thoroughly, but I wonder how those would differ. That'd be an interesting thing to look at. Because I'd assume that there would be some variation between ones that we find more like modern eruptions that are recorded versus ones in the geologic column, and what differences are between the two.
Right, and yeah, what characteristics of an environment would have to be there for it to be a distinct, non-blended layer that's thin.
How many dissertations are you going to pitch at me? I
I
can
don't
only
know.
get so many.
This is my first time being exposed to this topic, so I'm just a curious person.
We've already got like 6 PhD dissertations in queue at
Yeah,
the
yeah.
moment.
It's just because I mean the ideas you're presenting, they they present these corner cases that I find interesting to explore because I don't want to judge this versus other theories without at least some questioning of the edge cases, right? As with any logical theory.
No, and I think it's really intellectually honest of you, and I really appreciate you prodding and poking respectful questions that are in good faith questions. Really, this whole discussion that you've had since you've been up on the panel has been awesome. I really want to thank you for that. Some of these TikTok
Yeah, I'm
lives do
sure
not
you
go
get
this
some
smoothly.
pretty unfair attacks and whatnot on ad personal things. So I wanted to make sure that you know you were respected as a person, and you know I think the folks here, there's very few of us, but you know appreciate that you're approaching this with a real keen interest into geology, and it seems that you have quite a few questions to answer, as we said in the masters. How many master's thesis? So thanks for having me up, and I'm going to let you go and have a nice evening.
Yeah, again, get your phone charged. Appreciate you hanging out as long as you did. You take care. Alrighty. Awesome. That guest was great. Really appreciate having him on. And if I can chase him back down, I don't think I got the opportunity to give him a follow before he left. So if anybody wants to like send me his page, I want to make sure I follow him back. Real good stuff. Let me get my other background back up on the screen here. I was just thumbing through the chat to see if I could find him on there again. If not, all right. It should show me after the live ends for me. But let's go ahead and get my background back up and we'll interact with the chat again. Sweet. So topic, there we go. Thanks for waiting on me. I've got my background up. Topic is young Earth, biblical creation, global flood. The last guest and I just talked for good like hour and a half about geomorphology, which was not how I expected the night to go, but I am pleasantly surprised. Right. Yeah, I'm pro young Earth, but I'm not a flat earther, and I'm not going to talk about that topic on this live because it derails the whole night and we don't get anything done. If you got any questions for me, or tell me what you believe, or if you have a really cool scientific discovery that you want to talk about. I always love really like the last guest. I want to research it. He pointed out that there's evidence for the nickel iron core in the Earth not being perfectly spherical. And I hadn't heard about that before. He was saying that it was posted relatively recently. So I'm like, that's different. I wonder, I don't know what to do with that information, but it sounds neat. What I think about fossils, I think the vast majority of fossilized remains of living organic creatures are a direct result of the global flood catastrophe that occurred about 5,000 years ago. I think there's evidence to support that. I don't view the geological column as a representation of different eras of life progressing. I view them as a graveyard on top of a graveyard on top of a graveyard, all catastrophically laid down by flood flows as the land was being inundated during the flood. Just my take on it. I think that provides a better explanation for things like soft tissue and dinosaur bones, or relatively soft creatures like jellyfish and schools of fish, things like that are fossilized together, rather than a kind of just so business as usual over unimaginably long amounts of time kind of explanation for fossils. But I think they're really cool. There's some fun examples of fossils that I have a couple pictures of if you'd like to see them. So how come there are layers of sediment instead of just globs of fossils? There's small pocket examples of like globs of fossils. Like if you've seen the dinosaur monument in the western United States, that's a mass formation of fossils that are buried together in the same sediment deposit. But most layers are stratified, right? They're left to right, they're strata. The flood modeling that we're looking at is describing more of a tsunami wave, a pulse of a large amount of water dragging up sediment and ocean marine life inland and depositing it on land. And then the water recedes back into the ocean basins, leaving behind the creatures it dragged up and the sand grains and sediments it dragged up with it. And then another wave hits, and it's a packet on top of a packet on top of a packet. So like, for example, I was just showing the last guest some examples of cross-bedding. There it goes. So these are photos that I took of an example of cross-bedded strata. This is right off the highway, mind you. So this is level. And then the strata is on a diagonal. And this indicates what direction that the water was moving that deposited this strata. And then it was later carved away. In this case, carved away to make way for the road, but it exposes nonetheless layers that are consistent as they go across this area. So this would be, how much water did it take to deposit that much sediment? Where normally you're talking tidal flat layers that are a couple inches thick, and like modern tsunamis that aren't terribly thick. This is 15 feet thick. quite a bit different. Do I believe in tectonic plates? I do believe that there are tectonic plates. Most of our continental shelf, there's oceanic plates, there's fault zones, there's isostasy, where the plates move vertically proportionally to each other, or not subjectively to each other, and so on. But yeah, they're definitely a thing. One of the key differences is that we both agree that the continents were together at one point in the Pangea configuration. I just believe that they moved quickly a short time ago instead of very slowly over a very long period of time. So same starting and end conditions, but just a very different rate of process. I've got a picture for that. Hold on. I can find it. There it goes. That one. Tectonic plates are a part of the model, and it's a global flood model. It's not a pancake, and they do that. So let's see. Why are most species present in just a small strip and don't appear again in a different layer? That's a good question. So, for example, in the Cambrian layers, we're finding an abundance of aquatic life. So that ecosystem, if it were fully intact and articulated and flourishing life and just carrying on as if it's any other day, gets hit by a tsunami and it deposits all of that on land. When the next wave hits, is there an ecosystem left for it to pick up and deposit? No, it just got wiped out. So if it gets wiped out once, I wouldn't expect to see it repopulate that quickly in order to get deposited again. Just that would be my take on. It's one example. It's not going to cover everything, but that would be why I'd say you don't see the Cambrian explosion again because it gets wiped out once and it doesn't come back. So tectonic plate theory explains much of your claims. Well, yeah, it's the same concept. The difference is time, right? We're not looking at the tectonic plates at the speeds that we're seeing isostasy and horizontal movement today. We're talking about a catastrophic event that completely reshaped the planet in a very short amount of time that many cultures and ancient traditions across the world describe as this flood that destroyed the world. Everybody has this story. Everybody's got this story that the gods were mad or God was mad and they destroyed the earth with water and there was a few survivors. Like all the cultures have this story. I just believe they were describing an actual event that humans observed, and there's evidence of that in the rocks around us today. Let's see. Yeah, genetic novelties, morphological, are in a sequence. The only sequence that I can affirm that I agree I do see is a destruction of ecosystems from the sea to the land, from aquatic creatures and creatures that can't run and escape the cataclysm to the creatures who can, being buried in the higher layers. That I see, but I don't believe that is an indication that aquatic creatures became plants and land creatures that became dinosaurs and birds and warm-blooded creatures and the like. I don't think that connection stands. For example, you would need transitional fossils to represent that change. And there are very, very few that you could point to as even potentially being a transitional fossil, but that's the exception to the rule. The rule is when you find a creature in the fossil record, it remains unchanged until you either don't see it anymore or there's still living versions today with, if there's a rat that evolved into a bat, we should see fossils of brats along the way in that progression, but we don't. We only find one or the other of the living creatures that we do find. So that I would say is a challenge to believing that they're in some kind of sequence because the transitional fossils just aren't there. But what about the individual species? Like, why do you think species separate from each other? I'm not sure I understand your question, but what about individual species? Like, why do I think species separate from each other? So I think small scale, there's an incredible amount of diversity that can happen in kind. Like, we didn't have pugs a couple hundred years ago. They just didn't exist. We had wolves, but through selective breeding in a very short amount of time, within a few hundred years, we were able to produce a massive variety in speciation of dogs just from wolves. But I don't believe they'll ever evolve backwards and like get back to being wolves or something better. I think that they only degrade and become less and less fit through mutations over time, but not in an opposite direction where it'd be more beneficial. So in that instance, I think we do see them separate out, but staying within their kind. Like it's still a dog. A wolf to dog is still in that vein. It's not becoming a fish or a bird or anything of that nature. Let's see what else we got here in the chat. For example, you don't see Australopiths and Neanderthals in the same layer ever. Is that true? We've never ever found an example of Australopiths and Neanderthals in the same layer ever. I don't think that's true. If we find one piece of evidence that would counter that statement, though. So you're making a claim that we never have found an example of that. And it's really difficult to make always or never statements. Neanderthals always come later. If they were all living in the same area and died in a flood, then how did they end up stratified? Stratification during the flood is because it's a dynamic cataclysm. It's not like a bathtub filling up with water and draining with water. We're talking about catastrophic movements of land masses and earthquakes, dumping tsunami pulses that are hundreds of feet to thousands of feet high, inundating the land masses one after the other. It's making lots of packets of strata, not just one. And I would need to see what evidence you're pointing to claim this trend that you're claiming to see, that Neanderthals always come later and they're never in the same layer. Because I haven't seen that definitive evidence. If they were all living in the same area, we read that one. Sequenced genomes present strong evidence. What do you mean by sequenced genomes? I'm not familiar with that. My field of study is more so geomorphology, geophysics, and things of that nature. So biology is a little outside of my expertise. There's a very thorough record of transitional morphology in primate fossils. There's not, though. There's really not. So Lucy turned out to be a chimpanzee. Lucy didn't turn out to be a hominid fossil at all. She's just not human. It's just a chimp fossil. So saying that the Lucy fossil would count as a transitional form leading up to human evolution, the evidence just doesn't support that. And it's not a thorough record, though, of transitional morphology, especially in primates. You don't have it. We find human fossils, we find fossils of apes, but transitional forms, we haven't found one yet. You would know. You work with Lucy yourself? You work with Lucy yourself, is your claim? That'd be really interesting to have you see. All right. Looks like we got a guest request up in the box. I got to the bottom of the chat. I'm going to go ahead and bring you on Siasms. Hey, guest.
Howdy. As I say, invite Tess up. She's knowledgeable. Fantastic. I I'm not sure I get how stratification happens by these tsunami sort of events as you're implying, but it is very stratified, right?
Well, I'm sorry. What was your question?
The fossil record is very stratified. You had a question about why I said sequence genomes
Yeah.
are
Yeah. So,
informative.
what are you talking about with genome sequencing as evidence of the evolutionary paradigm?
Okay, so sequence genomes is kind of recent. We had the Human Genome Project finished in hand-wavingly early 2000s, but it was very expensive and very long to do this. But now we have sequence genomes of hand-wavingly 20,000 other extant species, right? And given the sort of lineage charts that we have, that this group came from that group, and that group came from the group before it, the sequence genomes really hold up those theories, right? We can see um, number, even by easy karyotypes, changes in number of chromosomes and big genome duplication events. You sort of mentioned tangentially that genomes only go down in quality over time, and I find that to be problematical. As an evolutionary biologist, um, these genetic novelties do arise and they proliferate. Um, so that's sort of evidenced by all these sequence genomes that are matching this whole new technology is showing exactly which was prospected by Linnaeus when he created these charts, and everybody else worked with it. It's just yet another angle, and it shows the same information, and that it was a very long time, right? It couldn't possibly have happened in 5,000 years.
Why do you say that? Basically, from a starting point that these creatures that we find in the fossil record already had the complexity built in, and the living creatures on the planet today are all a result of rapid speciation from a select few after that cataclysm. Why do you believe that that couldn't have been the case?
Um, so what do you go by? I'm Dan.
Yeah, my name's Dan. You say your name's Dan as well?
Yeah. Okay. Cool.
Oh,
Great
yeah.
name.
Makes it
so
easy.
So, Dan, the complexity that we see currently wasn't always there, in my opinion, right? And I think I would suggest really strong evidence from concurrent sources show this to be true. That complexity has increased over time, right? And so,
So you're saying that you don't believe the complexity we see today has always been there.
mhm.
What evidence do you have to support that that's true?
I think the old reference frame would be the fossil record, which you're disputing, right? You're
Okay, so you're
suggesting there's
saying
another means of that.
the
I'm
fossil
suggesting
record
there's another line of evidence, which is that from the genomes that we have of extant species, that they're not related, and it took time for these changes to happen. Um, that there's not a chance it happened in 5,000 years. We know how fast, by current observations, mutations occur, how they proliferate, etc. So even the human lineage specific thing, which is more of my interest group, right? So um, loss of a tail, right? That's a big thing. Why are the great apes different than other parts of the same related species of monkeys? Well, they don't have tails, right? So that's the great apes are orangutans, chimpanzees, bonobos, uh, humans, etc. We all don't have tails. We can specifically show what mutation occurred because all of these living extant organisms have it, right?
So there's similarities and differences. We have two eyes and a nose and a butthole. So do dogs. I don't believe that we're descendant from dogs just because there's
Oh, that's clear.
similarities between right between the two groups. So
Well,
what do you make then of any of the modeling for human growth population metrics? Like we have how many people, nearly 8 billion people alive on the planet today. Historically, how many people did we have 2,000 years ago? How many people were alive 3,000 years ago, and so on? How do you make sense of the human growth metrics?
agriculture would be the first one, right?
Okay, so what do you mean agriculture is how you're because you still you have a problem. From in your model, when do you believe the DNA code was finally modern enough to be classified as modern humans? When was the first modern human in your modeling?
Depending, and that's a great point of controversy, and I don't think you agree entire
Sure, just
agreement, but
ball.
I would hand wavingly say between 400,000 to 100,000, 130,000 years ago, right?
Okay. So I can work with that time range. So let's say the mean of that is like what, 200,000 years ago? We're talking.
Sure.
So at an average human growth rate for the population of, let's say it's 1.5 child per woman per generation. If we're taking that trajectory and you start with Y chromosomal Adam and mitochondrial Eve, if you've got two at that rate, what population would we expect to have on the planet today if, say, 200,000 years ago, we had DNA, for better or lack of terms, modern humans?
So I'm going to approach this in sort of an interesting way, I think. Prior to Darwin, there was another person who said, if rabbits who reproduce really quickly didn't have any predators, didn't have any nutrient unavailability, they didn't have starvation, they didn't have any adverse events, if they just reproduced, um, we'd be hip deep in rabbits, right? But that's not what happens, correct? Rabbits
Well, I mean,
reproduce really quickly, but we're not knee deep in rabbits.
right. So there's natural predators
Hmm.
and there's things that go on and so forth. However, if that's the case and there's natural predators to humans and
Hmm.
what's to stop them from just becoming extinct as a whole and just, the population dips down to there's no humans anymore or explodes
I
exponentially?
mean, that's a great sort of point. And what we can sort of, again, from secret genome studies, suggest is that there were small populations of humans at various times where bottlenecks, where it got down to a human population that may have been as small as 100,000, maybe as small as 10,000, maybe as small as 3,000. But we had the Ice Age happen, right, which is very adverse. There had to be adaptations for this. And cultural adaptations, right? So we're not just talking genetic adaptations. These are societal adaptations that are needed to make it through the stressors of this. What's important is this particular species of humans was able to do these societal adaptations. Writing was another big thing. Agriculture was a great thing, meaning that you weren't just hunting and foraging, but planting and harvesting crops, right? That creates
So
nutrient availability where rabbits, if they had that, we'd be knee deep in them, right? And
Well,
so,
I think that the advent of writing is actually challenging to your view because you would have to believe that for 200,000 years, 100,000 years plus, that no humans across the planet developed any kind of writing system or scrape anything into any stick anywhere. Like uh, wherever there's humans, you always find pictures of the male genitalia. You just don't have enough of them in the fossil record to justify there being people. I just don't think they're there. Um, it's challenging to me to think that not only do you have one people group develop an articulated dynamic language set that we find evidence of, like Aramaic, for example, and you have other completely independent language sets like Chinese and so forth on different places geographically on the planet all around the same time, about 5 to 10,000 years ago. If you're claiming people have been here for 200,000, it's just really odd that miraculously they all get language like some kind of like patch update, like Earth
mm,
1.2.5. We have written language now. It's challenging to that view, and in my view, I would point to all of the language that was already articulated. It was already fully formed, and this is them just dispersing out kind of from Mesopotamia, moving across the planet and populating across the planet, carrying their independent and unique languages with them.
I get that viewpoint and I get that criticism. I do think the consensus would be that um, some amount of genetic novelty, some change did happen. And we can point to particular gene sets, the FOXP4 gene, etc., which are very intricate. They're basically regular genes that change during early development. How far neuron systems move in early development, I mean during childbirth, right, or child development for post-conception. So those would seem to be, incredible, uh, unforeseen or unpredictable or unfathomable things. But these nuanced changes change the number of layers of neurons in the brain and allowed new connections to be made, particularly in memory systems. I think I would say that memory systems was um, the big change, in my opinion, in that the ability to recall far distant events in the past is sort of something that I don't think many other, um, I would even call other mammals sentient, and maybe birds too. I have parrots. I think they're somewhat sentient, but um,
There's some really smart birds out there.
there are some really. I have African gray. I have a Panama, and they use language contextually, and they're incredibly brilliant, but they're wired very differently, right?
Mhm. Yeah,
But
they're not making pottery out of mud and firing it in a campfire they started and using that to hold milk. Like
right,
there's just things humans do that humans have always done. As always, as long as we find evidence of humans, there's clay
I
pottery.
mean,
There's
how far do you
things we
back
make.
do you think fire has been in the fossil record? That maybe if you disagree with the science, I don't know, but um, how far back do you think the use of fire goes in the fossil record? At least by my opinion, even though you disagree with it, by the consensus record, it goes back almost 2 million years, definitely a million years,
I would like to see
and
what fossil or what you're looking at to point to evidence of like a fire. But I mean, lightning can spark a fire. That doesn't. It's not exactly the same thing as a campfire. I would say.
it would be records of fires in the community. In cooking, is at least evidenced by the fossil records you may dispute about 800,000 years old, meaning that
Yeah.
it would appear that from the bones that are found around these fires, that they were not just put into the fire, they were kept at a distance which cooked the meat but didn't destroy the bone, which implies cooking, right?
Maybe if I'd be curious to see that particular piece of evidence and how it's dated because the dating is really particular of like what we're using. Because right, do you date the rock? Do you carbon date the fossil itself? What are we using to gauge that metric? I'd be interested to see
Sure.
the people who've done the papers on that particular finding, how they came to that conclusion. Because maybe I want to analyze their dating method.
Right. And I would agree that dating methods are problematical, right? But mostly they seem to reach the same endpoint using different methods. So that questioning one particular aspect of they're using this, and I don't find that to be trustworthy if that's the case. But if two or three others are by different perspective reaching the same thing, you can kind of end up on a range, and the range is pretty consistent. So to answer your question that you're asking, I think my link tree on my bio has links to these articles. I'm pretty sure.
Okay. Yeah, I'll have to. I want
But
to take a look at the fire one. I'm particularly interested about like the evidence of cooking thing fossil. That sounds neat. I want to look at that.
mhm.
But I'm gonna pause this for a second. I need to check something. The live might say it's paused. All right, there we go. I'm back. But
Um,
I'm gonna wrap it up. I'm gonna have to get going
sure.
in here. You've been really polite and really pleasant, so this has been a nice conversation. I mean, opposition. Like I'm really of the opposing viewpoint. It seems to yours, but still, you've been very pleasant. My phone stand's not doing too well today.
I hear you.
But glad to hear. You said you've got birds. I've been loving the bird TikTok.
Oh yeah, on a personal front. Well, I put them to bed or I bring them out, but so they're 24 years old,
Oh
and
wow!
so they live to be about 70. I got tired of. I love dogs and etc., but I got tired of the emotional wrenching experience of losing one's familiar, one's pets that you get
Yeah.
connected to, and so I wanted a pet that would live a long time and was intelligent. And so I went the bird route, and I love it. They're absolutely fantastic.
I did not know that some of these birds can live up to what, 70?
Yeah.
Jeez, that is wild. I didn't like cats already get up into their 20s sometimes, but that's just that's a whole nother ballpark.
hmm
Jeez. Oh, that's awesome though.
So
It blows me away at what some
the
of these birds are capable of that I see people posting on with them.
oh, absolutely. Yeah, I hand fed these from they didn't even have feathers, um, and to where they did, and now like they're familiar with my routine. When I start gathering my stuff together, like goodbye, bye, see you later, Asa, bye bye, because they know what I'm doing. I'm getting ready to go.
Oh, that's
If
awesome.
they're hungry, they'll make microwave noises because they know I heat up food in the microwave.
They make the microwave.
They're manipulating me to make them serve them right. They're not dumb,
Oh, that's cool.
and they're cuddly. They like their tickles. They like affection, and
They have personalities too.
oh,
Like,
decidedly, yeah.
oh yeah. Oh, that's
But
phenomenal.
I would not. I don't generally recommend them as pets to people because they are pair bonding, right? So if has a moment and says, "Oh, I want this in my life," and they change their mind, that's so tough on the bird that
Oh.
I'm like, it takes commitment, right? So it's a commitment. It's a lifetime commitment.
Well, I'm glad you find with joy in those pets, and man, it, I love it when the birds learn how to cuss. I don't know. For some reason, that just gets me. It's one of my favorite things to to see those ones.
Mm.
But I'm gonna go ahead and wrap it up here.
Hey, good talking with
Hopefully,
you. You have a good
next
night.
time we'll be able to pull Tess up on the live as well.
hmm
But it's been great chatting. Wish you well.
Have a good night.
Bye. All right. Thanks, everybody. Thanks for being in the chat and leaving your comments. I hope you guys have a great night.